Hi everyone, let's solve this problem subsets 2. We have already solved subsets problem in one of our previous videos. If you haven't watched it, please watch it. I'll share the link in the description. So let's understand the problem statement. Given an integer array nums that may contain duplicates, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. So previously in the subsets there were no duplicates. This one has duplicates. Now let's try to understand the tree which we can have. The array is 1 2 2. Let's say I am at, there are two possibilities. One is take 1, one is do not take 1. Now I am at 2, take 2, do not take 2, take 2, do not take 2. Now here again take 2, do not take 2. But in this case, if I do not take is fine. If I take 2, what will happen? I am kind of repeating the same path as this one, right? If there are, let's say, additional elements 3, 1 2 2 3, 1 2 2, again I will have 1 2 3, 1 2, right? In this case again 1 2 3, 1 2. So if you observe, this particular subtree and this particular subtree is same. So all the paths on this side are take, all this side are do not take, right? So whenever you are skipping the elements, like not taking that element, you can just skip the, this is take, this is do not take. So in this case you can just skip this entire tree, so that in the take case it will be handled. We don't really have to worry about not take. So what can we do for this do not take case is that if I am here, if I am not taking this element, and if the next element is also same, I will just skip that and move forward. That's the only thing which we have to do apart from the previous code which we have written. So let me try to code it up and show you how it works. So it's again result is this, and we have one. Okay, we will define our backtrack function. We need nums, we need index, we need subset, we need result to insert into. So what will happen if index has reached our nums dot length, then we know that we have created one subset. We will just push into our result and return from here, because we don't really have to move forward. Otherwise, take the element subset dot push of nums of index, call the backtracking for the next elements, and subset dot pop element. So now we are done with taking a particular element at this index. Now we write for nums index plus 1 subset result. This is how we write, but the only trick here is we just have to ensure that while index plus 1 is less than nums dot length, and nums of I double equals to nums of I plus 1. We just have to do index plus equal to 1. We are just increment or plus plus. We're just incrementing the index when it is a element, duplicate element. In case of not taking that particular element, like I mentioned here, it's not take case. In this case, if we already are skipping an element, we can also skip further elements. That is all we have to do. Like, we don't need to go through this entire subtree, because that will be any which was covered here. Cool. Let's also write here backtrack of num index is 0, subset, initially it will be an empty array, then result, and we will return the result. But there is a catch here. The given array which we have taken is a sorted one. Let's say, for example, I'm given an array of 2 1 2. Then in this case, I will not be able to check if I and I plus 1 are same. So for that same reason, you just have to sort your elements. So this is how we sort in JavaScript. So we are sending the sorted elements to the backtracking algorithm. Sort of a comma b, a minus b, and we will be passing sorted in this case. Let's run it. Okay, it is not I, it should be index. Sorry, my bad. Index. Let's try to run it. Yeah, let's now try to submit it. Time and space complexity for this solution are also same. So time complexity is n into 2 power n, and space complexity is 2 power n to store all the subsets. That is all. Okay, I hope the solution is clear. Thank you.